Geometry Unit 2, Section 3, Angles and Triangles. So before we get to solving some example problems, let me run through some things that you might already know. First of all, the sum of three angle measures of any triangle is 180 degrees. The three angles in a triangle add to 180 degrees. And maybe we'll see a proof about why that is true later on. Not in this video, but probably in class. Next, when one angle of a triangle is a right angle, so in this case, let's say angle A is 90 degrees, the sum of the other two is 90. So basically, the other two angles of a right triangle are complementary, is what we call them. The acute angles of a right triangle are complementary. They have to add to 90 because, what we said above, if all three add to 180, and you got 90 in here, then the other two have to add to 90 together. The sum of the measure of two angles equals the measure of the opposite exterior angle. This is an important one. The state loves putting this question on our Regents, and basically what it's saying is that this angle here plus this angle here equals this angle here. The sum of they say the sum of the measures of two angles, this is actually from the state. I word this a little bit differently myself. I would say the sum of the two interior non-adjacent angles. Let me throw some numbers in here. Let's say that this is 50 and this is 60. Now this third angle, because we know they add to 180, would have to be 70. Because 50 plus 60 plus 70 is 180. So this angle out here would be 110. Because these form a straight line and they are supplementary, so they add to 180. Now because these two add to 180, and because these three add to 180, that means that these two together add to this exterior angle right here. If you didn't follow that, I'm going to do this in class as a proof. I don't want to spend the whole video showing you why this is the case, but it's kind of similar on how we proved vertical angles were equal with supplementary. If this plus this is 180, and this plus this is 180, then these two and this have to be the same, because 70 plus these is 180, and 70 plus this is 180. So these have to be the same as 110. So that's an important one. You'll see that in a lot of examples, so we'll talk about that one a lot. The next two are about special triangles. An isosceles triangle is a triangle that has two congruent sides. Not only that, it has two congruent angles. The angles opposite the congruent sides. We call them the base angles. But a lot of times you're going to hear the phrase, and we're going to write the phrase that angles opposite congruent sides. That's an ugly congruent wave. Let me change that. Angles opposite congruent, better, sides, angles opposite congruent sides of a triangle are congruent. Angles opposite congruent sides of a triangle are congruent. That's basically the base angles of an isosceles triangle are congruent. But you'll hear that a little bit more, I think. And so these are equal in measure. This third angle up here is not equal to the other two. That's called the vertex. Okay, so all angles in an equilateral triangle are equal in measure. Well, if an isosceles triangle has two equal sides, therefore two equal angles, an equilateral triangle has three equal sides, so that means it has to have three equal angles. And specifically, they have to be 60 each. Because if they're all the same, 180 divided by 3 has to be 60. And they all have to be the same, so they have to all be 60. Okay, how about a couple of examples here? First one, this is an exterior angle. Now, the angles inside the triangle we call interior. So if we see one kind of adjacent to it, adjacent is like next to, we call that an exterior angle. And what we learned over here is that an exterior angle is equal to the sum of the two non-adjacent interior. The exterior is equal to the sum of the two non-adjacent, meaning the one not right next to it, non-adjacent interior. So that would be 42 and A. So those angles together. So I can write a little equation here that 42 plus A equals 78. The two interior angles non-adjacent to the exterior, their sum equals that exterior angle. So 42 plus A equals 78, so we can minus 42 on both sides. And let me write that down here. If I minus 42 on both sides, then A equals 78 minus 42, which is 36. So angle A is 36 degrees. Okay, get rid of that little squiggly right there. Great. Next one. All right, remember what these little arrows stand for? These are parallel arrows. So what we're saying is that these lines, and I want to highlight these lines to really make sure you can see what's happening here. These lines here are parallel. And a line that touches both parallel lines would be called a transversal. So there's actually two transversals here. There's one here, and I see that Z, that zigzag, that makes me think alternate interior, and I could use that. And then this would also be considered a transversal. And that kind of makes an F pattern out of it if I take this one away, right? That makes me think corresponding. So using the relationships we learned from the parallel lines, that's how we're going to use this one. But first, we know that the three angles of a triangle add to 180. Now, I'm asked to solve for angle A here. But in some of these problems, you have to kind of take a couple of steps to get to angle A. I might have to find something before I get there. So a good process or a good strategy to use when you're really not sure what to do is just find any angle you can. And just this triangle over here, I see an angle that's 39 degrees. I see an angle that's 95 degrees. So I should be able to figure out this angle because I know they add to 180. So if I just type into my calculator 180 minus the two angles I do know, minus 95 and minus 39, that's going to get me my third angle, 46 degrees. So this is 46 degrees. Is that my answer? No, but it is going to help me because this angle is corresponding with this angle. So that's 46 degrees also. And since I have a little perpendicular square here, I know this is 90, and that can help me figure out what my remaining angle A is. Now these two triangles are not the same. They're close, but this is 90, this is 95. They're not quite exactly the same, but they do have that 46 in common, and that's because of the parallel lines and the transversal. So 180 minus these two is 44. So angle A in this problem is 44 degrees. Is that the only way to solve this question? No, it definitely is not. Could I have done something with alternate interior with this transversal, made this 39? Yeah, like say I didn't know the 46 here. I could have said these were alternate interior, that's 39, and then recognize that these three together have to add to 180 because they form a straight line. So 180 minus these two got my 46, and then with my 90, and this has to be 44. So I do think you had to get this 46 somehow, whether it was from the corresponding over here or with the three of these adding to 180 and the alternate interior over there. But the parallel was the key, one way or the other, and so you had to use that. All right, last one over here. What's happening? I want to find angle A and angle B. So, all right, a couple things. First of all, I think I can get angle A rather easily because this is a triangle. It's got cut off a little bit over there. But this is a triangle. And so 180 minus these, let's just use my calculator so I don't make any algebra mistakes. It's always embarrassing when it's being recorded. 180 minus 69 minus 58 is 53 degrees, so that's our angle A. 53 degrees, so I'll put that down there also. So what do we think about angle B? Well, there's actually three triangles in this picture. There's this little one here, and then there's a little one here, and then there's the big one. And this big one has a 53-degree angle, which we found. This angle, which I don't have all of it, but I have part of it, and then B. And that's really the key there, is this angle. If I could figure out that one with my 53 and B, have to add to 180. So what's this other one? Well, I figured that out because these have to add to 180 together. So again, because they're on a straight line. So 180 minus those. Oops, I gotta switch to a clicker. Delete the little red mark. 180 minus 93 minus 58 gives me that last piece right there, 29. So that's 29. Together, that would be 70, 87 together, right? Compare that 29 plus 58 is 87. And 180 minus that 87 and minus the 53 I found earlier gives me angle B has to be 40. Again, is that the only way to solve this question? No, it is not. You could have done supplementary with 69 to get this angle. We could have probably used some sort of exterior concept with that one over there. So I do believe we could come up with another method there. But we're just past the 11-minute mark, so I think that's enough for today. Angle B is 40 degrees, and I will see you guys later.